Let's discuss about acids and bases and their definition. According to Arrhenius' definition, an acid increases the concentration of hydrogen ions when dissolved in water. On the other hand, a base increases the concentration of hydroxide ions or OH- ions when dissolved in water. We also have the Bronsted-Lowry definition of acid and bases. A Bronsted acid is a proton donor, meanwhile a base is a proton acceptor. Let's analyze this one. We have here HCl in aqueous solution. So this AQ means this substance is in aqueous solution. In aqueous solution means this substance is dissolved in water. So as you observe here, so when HCl is dissolved in water, it dissociates into H plus and Cl minus, and this charge tells us that these are ions. So from a neutral compound HCl, it dissociates into ions. We call this process as ionization. So from the word ion, so this process forms ions from a neutral compound. So here we can observe from this reaction that there is an increase in the concentration of H plus ions, and this one is an acid. So an acid, again according to the Arrhenius definition, increases the concentration of H plus ions when dissolved in water. So again, when we dissolve HCl, it breaks into H plus and Cl minus. So HCl increases the concentration of H plus in the solution. That makes HCl an acid according to the Arrhenius definition. This H plus is a positive ion, and again these are dissolved in water. So these ions are mixed with water molecules. Remember that an H2O molecule or a water molecule is composed of oxygen atoms and hydrogen atoms. It's a neutral compound, but of course there's a separation of charge due to the difference in electronegativity. Note that oxygen is much more electronegative compared to the hydrogens, giving oxygen a partially negative charge. The hydrogens, they have partially positive charge on this molecule. And since this oxygen is partially negative, it can actually attract and it can capture. So this will capture these H plus ions in the solution. So it will capture on this one, forming an H3O plus ion. So again, ang H2O, it will capture an H plus. So obviously H2O plus H plus, that's H3O plus. So this one is a hydronium ion. So we can also write this one as this one. So it's the same thing. It's HCl. I just added this H2O because again, this H plus, this will also react with the H2O molecule in the solution. So again, here we have HCl. When we dissolve it in water, this dissociates, this breaks into H plus and then Cl minus. And again, this H plus is positive. This will be captured and it will react with the H2O, forming H3O plus, and of course Cl minus will be left as an ion here. Okay, so as you see here, so this H plus is again captured by H2O to make H3O plus. So on this equation, instead of the increase in the concentration of H plus, since again this H plus is captured by H2O, we can say that the increase in H plus is equal to the increase in the H3O plus. So we can also say that an acid increases the concentration of hydronium ion or H3O plus ion. So again, this is just the same. It differs on the perspective because here I just put into perspective the reaction of this H plus by the H2O molecule, but it's basically the same thing. So again, this is an acid based on the Arrhenius definition. So here we have the donation of H plus, and note that an H plus is composed, okay, let's go back to a hydrogen atom. A hydrogen atom is composed of one proton then one electron, and when we lose this electron here, this becomes an H plus ion, and what's left in an H plus ion is a proton. So we can say that this H plus is also a proton here. This one is a proton. So here HCl is donating its proton towards H2O. Let's write that one. So again, here's the HCl. That will be our donor here. Donor, and then as you observe here, this H plus or this proton will be accepted by the H2O. So this one is our acceptor on this case. And based on the Bronsted-Lowry definition, this HCl here, since it donates the proton or the H plus, this one will be our acid on this case, and this will be our base. So again, it's an acid when it donates proton, it's a base when it accepts the proton. And then if you look back here, so of course there is a reverse reaction. So if we go back here, or if we focus on the reverse reaction, this H3O plus, it can also, so from H3O it can become H2O, and that is when this H3O plus will donate its proton back to the Cl minus. So in this case, we actually have the concept of conjugate acid and bases. So to make it simple for everyone, just focus here from HCl naging Cl minus. So since this one is the acid, the Cl minus is the conjugate base. So this one is the conjugate base. This is the partner of the acid. Conjugate base. Conjugate base. And then this one we have H2O. Partners, then yung partner is the H3O. This is the base. So this one is our conjugate acid. Conjugate acid. So again, it's the conjugate acid, so it becomes an acid when we go to the reverse reaction, because on the reverse reaction, this H3O plus, it can donate its H back to Cl minus to form the HCl1. So here we have the concept of conjugate acid base pairs. So in this case, we have the acid, this one is the conjugate base, this one is the base, then this one is the conjugate acid. Let's observe another one. We have here ammonia or NH3 dissolved in water. So let's observe the change in the substances here. From NH3 it becomes NH4 plus. So what happened here? So we look into the number of hydrogens. So obviously there is an increase in the number of hydrogen. So we can say that this one accepted an H plus ion. Then from H2O, diba, H2O, that's 2H then 1 oxygen. After the reaction, there's only 1 oxygen then 1 hydrogen. So in this case, this other, let me just write this one, NH3. So in this case, this one H plus is transferred to this one. So this one is our donor on this case. So again, a proton donor, this one is an acid on this case. So the water is acid on this case. Well, this one accepted the proton or the H plus from H2O. This one is our base. And again, we have the concept of conjugate acid and bases. So we have NH3, NH3 with NH4. So this one is the base. So this must be our conjugate acid. Then here we have from H2O, naging OH minus. If this is the acid, then this one is the conjugate base. Okay, so here let's compare this one. So again, on this case, this one is an acid, and then this one is a base. This is based on the Bronsted-Lowry definition. Then here we have ammonia. This one is the base here, and then this one is our acid. Okay, if you look on the role of H2O here, on this case it's a base, and on this reaction it's an acid. So we call this property, or on this case we can call H2O as amphoteric. So amphoteric substances can be a base or a substance depending on the reaction. Okay, so let's answer the activity from the book. I gave it last time. So here we have, let's identify the conjugate acid-base pairs in the following reactions. We have H3O PO4 plus H2O forming H2PO4 minus plus H3O plus. Let's observe on the H3PO4. So from H3PO4 naging H2PO4, from tatlong hydrogen naging dalawa. So obviously it lose an H plus here, so this must donate, right? So this must have donated its hydrogen, H2O, from dalawang hydrogen naging tatlo, so meaning this accepted. So this one accepted an H plus. So donor, this one is the acid, accepted, this is the base here. And then again, just look for the similar compound H3O PO4. Then we have the H2PO4. Since this is the acid, this one must be the conjugate base. Conjugate base. Then we have H2O partners with H3O plus. If this is the base, this must be our conjugate acid. So these are the conjugate acid base pairs in the reaction. Another one, we have CO3 minus 2 plus H2O forming HCO3 plus OH minus. So here we have from, so this CO3 something naging HCO3. So there is an addition of hydrogen on this case. Then from H2O naging OH minus. Again, just observe here. Let's go from this one to this one. So there is an addition of hydrogen. So it must have accepted the H plus. Then from H2O naging OH minus, so it loses, so it donated its proton. So acceptor, this is the base here. Then donor, this one is the acid. Then if this is the base, then the partner must be the conjugate acid. Then if this is the acid, the partner must be the conjugate base. Conjugate base. Next one, we have this one, a HC9H7O4 partners with this one. So there is a loss, right? So on this case, this must have donated its H towards this one, because here from H2O naging H3O plus, so there is an increase in the H plus or proton. So this one must be the acceptor. So this one is the acceptor on this case. Donor, the acid, acceptor, the base. Then the partner of this one is this one. If this is the acid, then this one must be the conjugate base. Then this one is the base. The partner of the base is the conjugate acid. Conjugate acid.